trigonometric equation. Let's solve few more equations. First of all, let's quickly revise standard unit circle. Then we have considered here, all of you know standard unit circle. Now we have considered here x-axis and y-axis, rectangular coordinate system here. Now in the first quadrant, all trigonometric ratios are positive. In the second one, sine and cosec positive. In the third one, tan and cot. Fourth one, cos and sec positive. Next, we have considered that when ray OP makes angle theta with the x-axis, coordinates of P, OP makes angle, suppose this is the point P. So OP makes angle theta with the x-axis. If coordinates of P are x comma y, we know that x coordinate is equal to cos theta, y coordinate is equal to sin theta. Now if I consider coterminal angle, now coterminal angle means if I consider one complete rotation plus theta. One complete rotation plus theta, so 2 pi plus theta. So we consider again ray OP, that means we consider same point P for the coterminal angle. So when you consider one complete rotation, we come back to this point. So in that case, ratios will remain same. So ratios for coterminal angles are same. So any number of rotations you consider, this point, coordinates of this point will remain same. So you will get same ratios for the coterminal angles. Now let's start with the first equation. Solve tan theta is equal to minus 1. Tan theta is equal to minus 1. We want to find principal solution for tan theta is equal to minus 1. Now tan in this case is negative, and we know that tan is negative in which quadrant? Tan is negative in the second quadrant and in the fourth quadrant. So it is negative in the second and in the fourth quadrant. Next, we also know that tan of pi by 4 is equal to 1. Tan of pi by 4 is equal to 1. Right? So there are two possibilities for theta. Here, theta can be either this angle or it can be this angle. So there are two possibilities. So theta can be, now how much is this angle? The first possibility, theta is equal to pi minus pi by 4. I hope this point is clear. We want to consider this particular angle. Now we know that this angle which this line makes with the x-axis is pi by 4. So 180 or pi minus pi by 4 will give you this required angle. And the second possibility is this particular angle. So this is nothing but 2 pi minus pi by 4. Therefore, theta is equal to, now pi minus pi by 4 is 3 pi by 4 and 2 pi minus pi by 4 is 7 pi by 4. Therefore, and consider 3 pi by 4, 7 pi by 4. We know that since both these angles 3 pi by 4 and 7 pi by 4 belongs to the interval 0 to 2 pi. So we can say that these are the principal solutions of the given equation. So principal solutions are 3 pi by 4 and 7 pi by 4. Next example. Solve root 3 times cosec theta plus 2 is equal to 0. Everywhere we are going to find principal solutions. So everywhere our theta should lie between 0 to 2 pi. Now equation is root 3 cosec theta plus 2 is equal to 0. That means we have cosec theta is equal to minus 2 upon root 3. You may continue with cosec theta, or those who are not comfortable with cosec theta, they can convert it into sine. So sine theta will be minus root 3 by 2 and then you can continue. But we know ratios for cosec as well. So let's continue with cosec theta. Now cosec is negative in which quadrant? Cosec is 1 by sine theta, right? So cosec is negative in the third quadrant and in the fourth quadrant. So in the third, and possibility of getting angle theta is third quadrant and fourth quadrant. Cosec of which angle is 2 by root 3? Also we know that cosec of which angle is 2 by root 3. Cosec theta is 2 by root 3. That means sin theta is root 3 by 2. So theta is equal to sine of which angle is root 3 by 2? Sine of 60 degrees or pi by 3 radians. So cosec of pi by 3 is equal to 2 upon root 3. So these are the two possibilities. We can have either this angle. How much is this angle? So theta is equal to, this angle is pi plus, this is pi half rotation plus this angle. Now this angle is pi by 3. So pi plus pi by 3 is one of the possibilities, and the second possibility is this particular angle, which is nothing but this angle. This one is pi by 3. So 2 pi minus pi by 3. So theta is equal to 3 pi plus pi, that is 4 pi by 3, and the other possibility is 6, 3 to the 6 pi minus pi, that is 5 pi by 3. And you'll observe that both this 4 pi by 3 and 5 pi by 3 belongs to the interval 0 to 2 pi. Therefore, principal solution for this equation, principal solutions are 4 pi by 3, 5 pi by 3. These are the possible values for theta. Next, now let's consider multiple angles. Suppose we say solve, we have this equation, solve sin theta by 2. Sin theta by 2 is equal to, value is root 3 upon 2. We want to solve this equation, that means we want to find theta, principal solution for theta. So we know that theta, here theta lies between 0 less than or equal to theta less than 2 pi. We want to find principal solution. So theta should be between 0 to 2 pi. Next, now to solve this, we will consider, let's denote this angle with alpha. Let theta by 2 is equal to alpha. Now since theta lies between 0 to 2 pi, therefore since theta is between 0 to 2 pi, therefore we can say that, what about theta by 2? So 0 less than or equal to theta by 2 is less than pi. Therefore what we have is sine of alpha is equal to root 3 by 2, where alpha, theta by 2 is what? Alpha. So 0 less than or equal to alpha less than pi. So our alpha lies between 0 and pi. Now sine here is positive. Sine is positive in which quadrant? So angle should be either in the first quadrant or in the second quadrant. Okay. Also we know that sine of pi by 3 is root 3 by 2. Now let's use all this and let's find alpha. So what are the possible values for alpha? So alpha, when it is in the first quadrant, we get this particular angle which is equal to, so alpha is equal to pi by 3, and when it is in the second quadrant, we have this particular angle. This is nothing but pi minus pi by 3. This is pi by 3, this is also pi by 3. So this remaining angle is pi minus pi by 3. So possibilities for alpha is pi by 3, and second possibility 3 pi minus pi, that is 2 pi by 3. But we are interested in finding theta. So alpha is this, therefore what is alpha? Alpha is theta by 2. So we have theta by 2 is pi by 3, 2 pi by 3. Therefore theta is equal to 2 times, that means 2 pi by 3 or 4 pi by 3. Check whether both these values lies in the interval 0 to 2 pi. Do they lie? Yes. So, principal solution for the given equation. Principal solutions are 2 pi by 3 and 4 pi by 3. These are the possible solutions for theta. Next, let's solve sine. Now let's consider double angle. Sine of 2 theta is equal to minus half. We want to know principal solution. So we know that theta lies between 0 to 2 pi. Let's consider, like the previous case, let's consider alpha is equal to 2 theta. Therefore, here we have sine alpha is equal to minus half, where alpha lies between. Now, theta lies between 0 to 2 pi. So, what can you say about 2 theta? So, 0 less than or equal to 2 theta is less than 4 pi. That means our alpha lies between 4 pi. So, how many rotations we require? Now, when you consider one rotation, we get 0 to 2 pi, right? And now 4 pi we want. So, there will be 2 rotations, right? Sine is negative in which quadrant? Sine is negative in third and fourth quadrant. Third and fourth quadrant, sine is negative quadrant. Therefore, we can proceed like the previous one. We also know that sine of which angle is half? Sine of pi by 6 is equal to half. So using all this, we want to proceed. So we have x-axis, we have y-axis. This is the standard unit circle. Now, sine negative, so it can be either here, this particular ray we can consider, or this. So either angle this. Now how much is this angle? So alpha is equal to, this angle is equal to pi plus pi by 6. And other possibility is 2 pi minus pi by 6. This is the second possibility is here. This is the second possibility. So this particular angle is 2 pi minus pi by 6. So alpha is equal to 6 plus 7 pi, that is 7 pi by 6, or 12 minus 11, that means 11 pi by 6. So these are the possibilities for alpha, but we are interested in finding 2 theta. And what else we know? We know that alpha lies between 0 to 4 pi. So can we consider a few more points here? Now this is in one rotation. First rotation we got this values. So if I consider one more rotation, so this is in the first rotation, right? If I consider one more rotation, then I'll get alpha is equal to 7 pi by 6 plus 2 pi, or 11 pi by 6 plus 2 pi. That means in the second rotation, what we get is 7 pi plus 12, that is 19 pi by 6, and here second is 11 pi plus 12 pi, that is 23 pi by 6. These values possible in the second rotation, when we consider second rotation. So how many values for alpha possible? So alpha can be 7 pi by 6, 11 pi by 6, 19 pi by 6, and 23 pi by 6. Therefore, but what is alpha? How we define alpha? Alpha is 2 theta. So all these are the values for 2 theta. Therefore, theta can be half of these values. That means 7 pi by 6 by 2. That means 7 pi by 6 into 1 by 2, that is 7 pi by 12, 11 pi by 12, 19 pi by 12, and 23 pi by 12. So principal, and all these values will lie in the interval 0 to 2 pi, right? It should not exceed 24 pi by 12. Clear? So principal solutions are all these values possible: 7 pi by 12, 11 pi by 12, 19 pi by 12 and 23 pi by 12. Solve we have considered half angle, double angle and now triple angle. Tan of 3 theta is equal to -1. To find principal solution, that means we want to find solution for theta where theta lies between 0 to 2 pi. Let alpha is equal to 3 theta. So what we have here is tan of alpha is equal to -1 where alpha. Now 3 theta will lie between 0 to 6 pi. So alpha will lie between 0 to 6 pi. So range for alpha is 0 to 6 pi. I hope it is clear. Now tan is negative in which quadrant? Tan is negative in second and fourth. Second and fourth quadrants. Tan is negative in second and fourth quadrant. And also what we know is tan of pi by 4 is equal to 1. So let's use all this. X-axis, y-axis. So we have these quadrants. Now tan is negative in the second and in the fourth quadrant. And tan of pi by 4 is 1. So we know that this particular angle is pi by 4. This is pi by 4. Now possible angles here. Since it is in the second quadrant, we'll have to consider this particular angle. And how much is this? So alpha is equal to, now this particular angle is pi minus pi by 4. And the second possibility is this particular angle, which is nothing but 2 pi minus pi by 4. So alpha is equal to, we got 3 pi by 4 and the second possibility 8 minus, that is 7 pi by 4. This is when we consider first rotation, just one rotation between 0 to 2 pi. Then if I consider second rotation, I'll get 3 pi by 4 plus 2 pi. 7 pi by 4 plus 2 pi. So we get 11 pi by 4 and 15 pi by 4. 11 pi by 4, 15 pi by 4. This is in the first rotation. These values in the first rotation, these are the values in the second rotation. Now, how many possible rotations are possible? 3 rotations. So we can continue with one more. And the next 2 points will be 11 pi by 4 plus 2 pi, 15 pi by 4 plus 2 pi. So we get 11 plus 8, 19 pi by 4, 15 pi plus 8, 23 pi by 4. See that it is not exceeding. Now it should not exceed 6 pi. Alpha should not exceed 6 pi. Is it exceeding 6 pi? No. If you get 24 pi by 4, then you get 6 pi, right? So it is not exceeding 6 pi. So these are the values in the third rotation. So let's list them, all these values. So alpha can be 3 pi by 4, can be 7 pi by 4, can be 11 pi by 4, 15 pi by 4, then 19 pi by 4 and 23 pi by 4. All these are the possible values for alpha. But we want possible values for theta. So 3 theta is equal to all this. Therefore theta is equal to dividing all these values by 3. So we get 3 pi by 12, 7 pi by 12, 11 pi by 12, 15 pi by 12, 19 pi by 12 and 23 pi by 12. So principal solutions in this case are all these values. 3 pi by 12, you may simplify this. So pi by 4 you get. Then 7 pi by 12, 11 pi by 12, 15 pi by 12, 19 pi by 12 and 23 pi by 12. All these are the possible solutions for the given equation. Next, solve. Let's consider higher order. Now cosec of 4 theta is equal to minus 2. Principal solution we want to find, so we know that theta lies between 0 to 2 pi. Let alpha is equal to 4 theta. So now our equation is cosec of alpha is equal to minus 2, where alpha lies between, now theta is between 0 to 2 pi, so 4 theta will be between 0 to, so alpha is between 0 to 8 pi. That means how many rotations we'll have to consider? 0 to 2 pi is the first, next is 4 pi, 6 pi, 8 pi. So total 4 rotations we are going to consider. So since cosec is negative in which quadrant? Cosec means 1 upon sine. So you'll have to consider this ratio negative in which quadrant? So it can be in third quadrant, in the third, or which quadrant? Or in the fourth. Cosec negative either in the third or in the fourth. Also we have cosec of which angle is 2. Cosec of which angle is 2? Cosec of pi by 6 is 2. Now using all this we will proceed. So these are the possibilities. Let's see, we have cosec negative value possible in third quadrant and fourth quadrant. These are the two possibilities. Next, how much is this angle? Has to be pi by 6, right? Next, so first possibility for alpha is we can have this angle which is nothing but, so alpha is equal to, this is pi plus pi by 6. And the second possibility is whole is 2 pi minus this. So you get 2 pi minus pi by 6. So possibilities for alpha 7 pi by 6, or this will be 12 minus 1, that is 11 pi by 6. So in the first rotation we got these values, right? When we have first rotation, one rotation. If I consider second rotation, so other possibilities 7 pi by 6 plus 2 pi. That means what we are considering here is coterminal angles. Then 11 pi by 6 plus 2 pi. So we get 7 pi plus 12 pi, that is 19 pi by 6, and then this will be 23 pi by 6. This is in the second rotation. Third rotation will be 19 pi by 6 plus 2 pi, 23 pi by 6, 23 pi by 6 plus 2 pi. That means what we get is 19 plus 12, this is equal to 31 pi by 6. And second possibility 23 plus 12. So that means you get 35 pi by 6. This is in the third rotation when you consider third rotation. Next, one more possibility. It is also equal to 31 pi by 6 plus 2 pi, 35 pi by 6 plus 2 pi. Where do we have to stop? Alpha can take value till 8 pi. 8 pi means, let's consider that also. 8 pi means how much you should get? 48. It should not exceed 48 pi by 6. Okay. So 31 pi plus, now this is 12. That means we get 43 pi by 6. And this will be 35 plus 12. That means we get 47 pi by 6. This is in the fourth rotation. So all these are the possible values for alpha. So let's list them. So alpha can be, alpha is equal to 7. Alpha is equal to 7 pi by 6, 11 pi by 6, 19 pi by 6, 23 pi by 6, 31 pi by 6, 35 pi by 6, 43 pi by 6, 47 pi by 6. These are the possible values for alpha. So 4 theta is equal to all these values. Therefore theta is equal to, so theta is equal to, dividing all this by 4. So we get 7 pi by 24, 11 pi by 24, 19 pi by 24, 23 pi by 24, 31 pi by 24, 35 pi by 24, 43 pi by 24 and 47 pi by 24. All these are the possible solutions for the given equation. So, principal solutions are all these values: 7 pi by 24, 11 pi by 24, 19 pi by 24, 23 pi by 24, 31 pi by 24, 35 pi by 24, 43 pi by 24, 47 pi by 24. All these are the possible solutions for the given equation, that is cosec 4 theta is equal to minus 2. Let's solve one more. Solve tan 5 theta is equal to minus 1. Tan 5 theta is equal to minus 1. Principal solution. So we know that theta lies between 0 to 2 pi. Let alpha is equal to 5 theta. Therefore our equation becomes tan alpha is equal to minus 1, where 5 theta will lie between 0 to 10 pi. So our alpha will lie between 0 to 10 pi. How many rotations will have to consider? 5 rotations now. Now tan is negative in which quadrant? Tan is negative in which quadrant? So it should be either in the second, or the other possibility is fourth quadrant. Right? Tan should be in the second, or angle should be in the second or in the fourth quadrant. Also we know that tan of which angle is 1? Tan of pi by 4 is equal to 1. Now using all this, we'll proceed. So we have this standard unit circle, we have x-axis, y-axis, and now we are going to consider second quadrant and fourth quadrant. And we know that this particular angle is pi by 4 radians, and we are interested in this particular angle. So alpha can be either this. How much is this angle? So alpha is equal to, this will be pi minus pi by 4, or second possibility is alpha can be 2 pi minus pi by 4. That means it is equal to, alpha can be 3 pi by 4 and 7 pi by 4. These are the possibilities when you consider angle between 0 to 2 pi, that is first rotation. Other possibilities are 3 pi by 4. Alpha can also be equal to, we have to consider 5 rotations. So other possibilities 3 pi by 4 plus 2 pi and 7 pi by 4 plus 2 pi. 2 pi, that is equal to 11 pi by 4 and 15 pi by 4. First rotation, this is second. Next, alpha can be third rotation, it will be 11 pi by 4 plus 2 pi and 15 pi by 4 plus 2 pi. So other values possible, 11 plus 8, so 19 pi by 4 and 15 plus 8, that is 23 pi by 4, third rotation. Other possibilities 19 pi by 4 plus 2 pi, 23 pi by 4 plus 2 pi. So other possibilities 19 plus 8, so that means 27 pi by 4 and 23 plus 8, 31 pi by 4, fourth rotation. One more is possible, 27 pi by 4 plus 2 pi, 31 pi by 4 plus 2 pi. So we get 27 plus 8, 35 pi by 4 and 31 plus 8, 39 pi by 4. Is it possible? Can we have this? Yes. We can't go beyond this. If it is 49 pi by 4, then we get 10 pi, right? So it is less than 10 pi. So all these are the possible values for alpha. Therefore, alpha can take all these values. Therefore, alpha, that is equal to 5 theta, can take all these values. Let's list them. 3 pi by 4, 7 pi by 4, 11 pi by 4, 15 pi by 4, 19 pi by 4, 23 pi by 4, 27 pi by 4, 31 pi by 4. We have two more, 35 pi by 4, 39 pi by 4. Therefore, principal solutions, that means value of theta. So principal solutions, so theta can take values. Now we have to divide by 5. So we get 20. 3 pi by 20, 7 pi by 20, 11 pi by 20, 15 pi by 20, 19 pi by 20, 23 pi by 20, 27 pi by 20, 31 pi by 20, 35 pi by 20 and 39 pi by 20. These are the possible values for theta. I think principal values for given equations now you can find. Even though there are multiple angles, you can proceed. I hope all this is clear.